Okay, so these are the lesson 25 practice problems. So number 1, it says Joey solved the radical equation the fourth root of x equals 3. Review his work carefully and then answer the question. So line 1 is the original problem right here. And then in line 2, he changes the fourth root of x to the 1/4. And then 3 stays the same. And then in line 3, he takes both sides and he raises them to the fourth power. And then in line 4, he ends up with x equals 81. So in the video notes, I explain it a little bit differently. I don't go through like this process right here because it's not super necessary. It just kind of adds an extra step. But I wanted to include it here because there is a question that like looks specifically like this on your checkpoint. So at the bottom it says, why did Joey use the exponent of 1/4 in line 2? So it's referring to like why did he change from like x to the the fourth root of x to the 1/4. And it's because they're equivalent. So anytime you have like a fourth root, you can change it to an exponent. So the pattern is like if you have, say, the square root of x, it's the same thing as x to the 1/2 power. Or if you have like the cubed root of x, it's the same thing as x to the 1/3 power. And then if you have the fourth root of x, it's the same as x to the 1/4 power, and so on. You could do like the fifth root, sixth root, seventh root, whatever you want. So that's what he does. So I think the correct one, I don't remember exactly, but for this one, the explanation is A. So just going through them, A says Joey needed to rewrite the radical as an exponent to solve the equation, and an exponent of 1/4 is equivalent to the fourth root of a number. So that's the best reasoning there. Going through the rest of them. So B says he needed to rewrite the radical as an exponent to solve the equation, and an exponent of 1/4 is always used. Not necessarily. The 1/4 was used because it was a fourth root. If it was a different type of root, 1/4 would not be used. C, Joey needed to rewrite the radical as an exponent to solve the equation. An exponent of 1/4 is used because the equation will be divided by 4. No, because you can even see in line 3, like, you use an exponent of 4, you don't divide by 4. And then D, Joey needed to rewrite the radical as an exponent to solve the equation. An exponent of 1/4 is used because the equation will be multiplied by 4. Same reasoning there as like why C is not correct. We're not going to multiply by 4. We're going to raise both sides to the fourth power eventually. And then to kind of go back to like compare this to the way that I do it in the video. So you don't have to change it to a rational exponent. That just means like a fraction exponent like we did in line 2. You can really just solve it as is. So like if I had the fourth root of x equals 3 and I wanted to solve it means like getting x by itself. So I'd want to cancel out the fourth root. So the inverse of a fourth root is a fourth power. So I'd like raise both sides to the fourth power. And then the fourth root and the fourth power, those would wipe each other out. And then we'd be left with x equals, and then 3 to the fourth power, that means 3 times 3 times 3 times 3, like 4 3's multiplied together. So it ends up being 81, which is like the same answer they get here. It's really like the same step they do for like line 3 as well. Like I said, just adding in that like line 2 is kind of an extra step that's not always necessary. If you prefer to do it that way, you can. I just won't necessarily do it because I want it to be a little bit more efficient. All right, so number 2, find the solution to the equation 4 times the square root of x minus 7 equals 12. So we want to solve for x, so this means we want to isolate it. X is inside of a radical, so I'll have to cancel out the radical at some point, but before I do that, I will want to cancel everything out around the radical. So essentially like isolate the radical. So right now I have a 4 that's being multiplied by the radical. So to cancel out multiplying by 4, I'm going to divide both sides of the equation by 4. 4 divided by 4, those will cancel, and then I'll be left with the square root of x minus 7 equals 12 divided by 4, so 3. And then now the radical, that's like the square root symbol of the radical, is isolated, meaning there's nothing outside of it on that left side of the equal sign. So if that's the case, then I can go ahead and cancel it out. So I would cancel it out using inverse operations. So the opposite of square rooting something would be squaring something. So I'd have to square both sides. So squaring the radical is just going to cancel it out. And since the radical doesn't have a little number next to it, it's a square root. If you don't see a number, it's a square root like 2. Anything different than a square root, you would see a number like a cubed root or a fourth root. So it cancels out the radical and it leaves me with just x minus 7. And then over here, the like 3 squared, that means 3 times 3, so that would be 9. And then now I just want to get get the x completely by itself, so I want to cancel out that minus 7 by adding 7 to both sides. I would bring down the x. The minus 7 plus 7 would cancel out, and then I'd be left with x equals 9 plus 7, so 16. So final answer would be x equals 16. With radical equations, you do want to like check your final answer because you can end up with like extraneous or invalid solutions. So you check it by putting it back into the original equation. So the original equation was 4 and then times x minus 7 equals 12. And we ended up with x equals 16. So we'll put the 16 there. So it'd be 4 times the square root of 16 minus 7 equals 12. And what I'm gonna do is just simplify like this left side and see if it ends up equaling 12. So let's simplify the inside of the radical. So it'd be 4 times 7, or 16 minus 7 is 9 equals 12. Then I would take the square root next, so it'd be 4 times the square root of 9 is 3, just a regular 3, no more radical. So the square root of 9 turns into 3, and then equals 12, and then 4 times 3 does equal 12. So we checked in our answer, made each side of the equal sign like equal, so it is a valid solution. So it would just be x equals 16. Okay, and then number 3, I think this one is pulled exactly from your checkpoint, so just double check that if it looks familiar. It is. So Anna solved the equation, the square root of x plus 56 equals 16, and found the solution x equals negative 40. However, when she checked the solution, she realized that it does not satisfy the equation. Review her work carefully and then answer the question. I forgot to put the question, so I'm going to pause the video really quick. Okay, so the question is essentially asking what is her mistake. I just didn't put that final part. So what mistake did she make? So line 1, that's the original problem. So it's the square root of x plus 56 equals 16. And then line 2, she changes out the radical for a 1/2 power, which we talked about up here, like a square root is the same thing as raising something to the 1/2 power. So that's fine that she did that. You don't have to do it, but it's fine that she did it. So the x plus 56 is being raised to the 1/2 power instead of being inside the radical, so that's okay. And then in line 3, what she's doing is she is canceling out, whether you think of it as a radical or you think of it as like a 1/2 power, she is canceling out by using the inverse of it, which is squaring it. But the problem is that whatever you do to one side of the equation, you have to do to the other, and she doesn't square the other side of the equation. So that 16 doesn't have an exponent over it, and that's her mistake, is that she should have raised both sides of the equation to the second power, so that she was able to keep the equation balanced. So I'm going to finish out solving this, just get an extra example in here. I'm just going to take it from line 1. So the square root of x plus 56 equals 16. And then again, you can change it to like x plus 56 to the 1/2 power. It's not essentially necessary, so I'm going to skip that step. And I'm just going to skip to what she does in line 3, but just do the correct version. And so in line 3, she squares the square root of x plus 56 to get rid of the radical or get rid of the 1/2 power. But whatever you do to one side of the equation, you have to apply that operation to the other side. So squaring the radical or the 1/2 power is going to cancel it out. So it leaves us with just x plus 56 equals 16 squared. I think that's 256. And then we're trying to solve for x, so we want to cancel out that 56 that's being added. So I'd subtract 56 from both sides. these will cancel out, and then bring down the x equals 256 minus 56 leaves me with 200. So I end up with x equals 200, and then we'll just double check that one to be safe. So we check it by putting it into the original equation. So the original equation was x plus 56, so I'm going to go ahead and put our x in there. So it's 200 plus 56, or the square root of 200 plus 56 equals 16. 200 plus 56 is 256 equals 16, and then if I square root 256, I get 16. So I end up with 16 equals 16. So that checked worked, so it just means that our correction worked. But again, just one more time, the mistake that they're looking for in this problem is the fact that she did square the left side of the equal sign in line 3, but she didn't do it to the other side of the equation, and you have to do it to the other side of the equation as well to keep the equation balanced. All right, and then number 4, what is the value of x in the equation? Square root of 7x minus 12 equals x. So we talked about how if you have a radical you want to cancel out, you would square it, but you want to make sure it's isolated first. Isolated just means there's nothing outside of the radical on that side of the equal sign. So there's nothing right here, or there's nothing added after the radical that's not underneath it. I can't cancel out anything inside the radical until I cancel the radical itself out. So radical is isolated, so I'm going to go ahead and square both sides. And so squaring the radical is going to cancel it out, and it's going to leave me with just the stuff that's inside exactly as is. So 7x minus 12 equals x squared. And then now I have a quadratic because I have an x squared term. That's what makes it a quadratic. So I'd want to get this in standard form. And that means that everything goes on one side of the equal sign and the other side would be 0. Typically, we want the x squared to be positive, so I'm going to leave that in its spot, and then I'm going to subtract the other stuff, subtract/add the other stuff over. So I'm going to subtract 7x. I'm going to subtract it just like right here. I don't subtract it from the x squared because they're not like terms. And then I would need to add the 12 since that was a minus 12 in order to cancel it out. So 7x minus 7x, that cancels. Negative 12 plus 12, that cancels. And then I end up with 0 equals x squared minus 7x and then plus 12. And then now I have a quadratic. So again, x squared, and it's in standard form now, meaning it goes from x squared down to x down to the constant. And this is a trinomial, so I'm going to try to factor it. So standard form of a quadratic is a x squared. I'm going to write it up here actually. So ax squared plus bx plus c. So in this problem, a is, well, in all problems, but a is the coefficient of x squared. And we don't see a number there, so that's just 1. And then b is the coefficient of x. So in this case, b is negative 7. And then c is the constant term. That's the one that doesn't have a variable attached to it. So c would be 12. So when a is 1, like we have here, when you go to factor it, you just need numbers that multiply. Actually, I'm going to write it down here. So multiply to c, but add up to b. So whenever a is 1. So we want to find numbers that multiply to 12, but add to negative 7. So if you're not sure, I would make a list of all the numbers you can think of that multiply to 12. So you could do 1 times the number always, and then 2 times 6, and then 3 times 4. So if they're multiplying to a positive 12, that means both factors, like 1 and 12, 2 and 6, 3 and 4, they would both need to be the same sign. So either both positive or both negative. And since they're supposed to add up to negative 7, we're going to make them both negative. So we'll do negative 3 and negative 4. So negative 3 times negative 4 would be a positive 12. But negative 3 plus negative 4 would give us that negative 7. So if we add them together. And then when we go to factor this, the like 1x squared or just x squared, that breaks down into x and x, because factoring is like doing the opposite of foiling. So if I were to FOIL this back, x times x would bring me back to x squared. And then the numbers that we found over here, those would fill in the rest. So since they're -3, -4, one factor would be a -3, and one factor would be a -4. And it doesn't matter like which parentheses I put it in first, so like I could do x minus 4 first if I wanted to, that's the same outcome. And then now if I want to solve, I'm going to take each factor and set it equal to 0. So this is one factor, and this is another factor. So they both get set equal to 0, so it'd be x minus 3 equals 0, and x minus 4 equals 0. So again, one factor x minus 3, one factor x minus 4, they both get set equal to 0. And then I would want to solve each one separately. So I would want to cancel out the -3 by adding 3 to both sides, and that would give me an x equals +3. And I would want to cancel out the -4 by adding 4 to both sides, and that would give me an x equals +4. So we end up with two solutions. We end up with x equals 3, and we end up with x equals 4, and then of course we want to check both. It's pretty likely when you end up with two different solutions that one of them doesn't work, so we definitely want to check here, even though it is a little bit extra work. So the original equation, it was 7, see if I can get this to work, 7x minus 12 equals x. And then I'm just going to copy that over really quick because like I said, we have to do two checks, like one for each answer. Okay, so for the first one, I'll check x equals 3, so I'll put a 3 in both of those x's. So it'll be the square root of 7 times 3 minus 12 equals 3. So again, the 3 went into both of the x spots. So 7 times 3 is 21, minus 12 equals 3. Square root of 21 minus 12, so 21 minus 12 is 9 equals 3, and then the square root of 9 is 3. So we end up with 3 equals 3. So that one works, that's okay. And then for the second check, we need to check the second x value that we got, which was 4. So we'll put 4 in for both the x's. Oh, this one actually, both of them might work. That's kind of nice. Okay, so 7 times 4 minus 12 equals x. Oops, not equals x, but equals 4. So again, we put the second solution in for both x's. So we'll do 7 times 4 is 28 minus 12 equals 4. 28 minus 12 is, what is that, 16? Equals 4, and then square root of 16 is 4. So we end up with 4 equals 4. So both of those ones work, which is kind of nice that we didn't just do that for no reason. So for what is the value of x in the equation, we end up with x equals 3 and x equals 4, because both of them worked in the check. Okay, so number 5, find the valid solution to the equation the square root of x plus 6 plus, or I can't read, the square root of x plus 6 minus x equals 0. So I'm just going to rewrite it down here just because that space got like a little bit cramped by the previous problem. So the square root of x plus 6 minus x equals 0. So I talked about before how before we cancel out a radical, you really want the radical to be isolated, so you don't want anything else like outside of the radical on that side of the equal sign. And right now that minus x is outside of the radical, so I do want to cancel it out. So if I want to cancel out just a x or a minus x, I have to add x to both sides. And then I would just bring down this entire radical, so the square root of x plus 6, and then the minus x plus x cancels out. And then I would have equals 0 plus x, so x over here. And then now you can see it looks really similar to the previous problem where we have a radical on one side and then just an x on the other side. So since the radical is now isolated, I'm ready to go ahead and cancel it out by squaring both sides of the equation. So squaring the radical is going to cancel out the radical and leave me with just the stuff that was inside of it. So x plus 6 equals x squared. And then same thing as the previous problem, now I have a quadratic, so I want to get it in standard form, which means everything on one side of the equal sign. I want that x squared to be positive, so I'm going to cancel out the x and the plus 6. So I'm going to cancel out the positive x by subtracting x from both sides. And then I'm going to cancel out the positive 6 by subtracting 6 from both sides. And these will cancel out and leave me with just 0 over here, which is what I want. And then I have the x squared, and the like minus x and minus 6 is just going to go after it since there's no like terms to subtract them from. So minus x minus 6. And so now we have our quadratic in standard form, and again, a is 1, just like the coefficient of x squared. So standard form is like this formula up here. Feel free to pause the video to review like that section of the previous problem. So a is the coefficient of x squared, which is 1, and then b is the coefficient of x, which that's negative 1 since we don't see a number there. And then c is the constant, which is the number that doesn't have a variable attached to it, so that would be negative 6. And so since a is 1 again, I need numbers that multiply to c but add up to b. So in this case, I want to multiply to negative 6 but add up to negative 1. So I'm going to make a list of all the factors of just regular 6 for now. So it'd be 1 and 6, and then 2 and 3. And if they're going to multiply to negative 6, I need to make one of the, one out of each pair negative. So if I want them to add up to negative 1, I want to pick the numbers that have a difference of 1. And then if I want them to add up to a negative 1, I make the bigger number negative. If I wanted them to add up to a positive 1, I would make the smaller number negative. So 2 times negative 3 is negative 6, but 2 plus negative 3 is negative 1. So that's our pair that works. And then again, this 1x squared term, we're just doing the opposite of FOILing, so that breaks down into x and x, because if I were to multiply this back, x times x would bring me back to x squared. And then the pair that I found that works, we'll fill in the rest of the parentheses, so there's a positive 2 and a negative 3. So now it's factored and we're able to solve completely for x. So x plus 2, set that factor equal to 0. And then the other factor, x minus 3, set that factor equal to 0. And then solve each one separately. So for x plus 2, we'd want to cancel out the plus 2 by subtracting 2 from both sides. And then that would leave me with x equals negative 2. And then for x minus 3, cancel out the minus 3 by adding 3 to both sides. So that would leave me with x equals positive 3. So once I solve both, I end up with x equals negative 2 and x equals 3. And I just want to check both answers now. So I'm going to do the check kind of up and to the left. So I'm going to separate this off, and then I'm going to copy down the original equation really quick. And it's up to you. So if you want to check it in this original equation, that's fine. If you want to do it from here, where we had the x on the other side of the equation, that's also fine. I'm just going to do it from the original. So the square root of x plus 6 minus x equals 0. And then I'm going to just copy that. So oops, copy that because we'll have to do it twice, one for each solution. So we'll do x equals negative 2 first. So it'll be negative 2 plus 4, or sorry, plus 6, and then minus, and then x is negative 2, so it'll be a double negative, equals 0. So we put the negative 2 in for both the x's, just be careful with the double negative. And then negative 2 plus 6 is 4. It's the same thing as 6 minus 2. And then minus negative 2, so this double negative right here, double negative turns into plus. That would turn into plus 2 equals 0. And then the square root of 4 is 2, plus 2 equals 0. And so we end up with 2 plus 2, which is 4 equals 0. So that one's not true. So that's an example of a check that did not work. And if you're thinking okay, well, can't the square root of 4 also be negative 2? And it can, you do want to write both, like when you're solving, but when you do the check, you just take what's called like the principal value, which is just the positive version. So whenever you're checking and you take the square root of something, you just take the positive answer. So we did the check did not work because we ended up with 4 equals 0. So that -2 is going to be invalid. And then now we just need to check the x equals 3. So 3 will go here and here. So it'll be the square root of 3 plus 6 minus 3 equals 0. 3 plus 6 is 9 minus 3 equals 0. Then the square root of 9 is 3, and then minus 3 equals 0, and then 3 minus 3 is 0. So we end up with 0 equals 0. So that check does work because we ended up with the same like answer on each side of the equation. So the x equals 3, that answer is valid. So it says find the valid like solutions to the equation. So the answer we would choose for this one would have to be like the x equals 3. We would not pick like the -2 and the -3 because the -2 is not valid.